Is that a little too loud?
You got it?
Okay, Al's on it.
Got it. Okay.
Okay, thanks, Wyatt. Also, looks like my open office presentation got a little lost in translation here. I got a bunch of, what do you call them, dots everywhere, bullets everywhere for some reason now. Either way, we're going to run with it. Once again, my name is Travis, and we're going to be talking about layer 7 attacks. And you don't have to worry about writing any of this down. First of all, they're going to be recording everything. So sit back, kind of take it all in. And also, I'm going to be reflecting everything you see here up on my site. And I'll show you a link at the end where you can get all this information. So first, a couple of slides at the beginning. Disclaimer, this in no way reflects upon my employer. All this was done on my own. So, and one little pub here, UNC Charlotte. I graduated from there in information technology. They have a concentration in information security, and I graduated in 2006. And they have a scholarship at the school they do through the government called the Cyberdefender Scholarship. And yeah, they're going to give you $15,000 to $13,000 a year, and depending on if you're grad or undergrad, and that's going to be for 2 years. So maybe like your last 2 years if you're undergrad, or 2 years if you're graduate. And they're going to pay for your schooling and your books and everything on top of that. And then in turn, you'll then work for the government for 2 years. And now it's local, state, or federal, so you have a lot of options. I know guys that went to work for NSA, but I know some guys that went to work for the post office. And so there's a whole range of stuff you can get into. It's a really great program. I didn't do it, but I know some guys did. And also, they have an international hacking competition in 2006. They came in 4th, which is okay, but they beat out schools like NC State and Georgia Tech, which, either way. But check it out for yourself. If you like the program or not, whatever. I just figured I'd throw one out there for the alma mater. Okay, so why this talk? Basically, everybody is focusing their efforts on layer 7 now. Publications have it 80, some have it 60. Take it conservative. Even if it is conservative at 60, everybody's attacks are now focusing at layer 7. They're not doing these Cisco iOS attacks and SNMP attacks. Those are still out there, but now all the attacks are occurring at layer 7. So that's kind of the reason why I'm giving this talk. And hopefully, I may get to exploiting weak cookies. We'll see. Because I usually use WebScare for that. I don't think it's on here, but I'm going to try to demo 2 attacks. The first one is utilizing cross-site scripting and SMS. Cross-site texting is what I call it. The second scenario we'll be looking at is exploiting weak cookies within an application. So the first scenario we're going to go over here is where an attacker gets notified through a text message of a successful phishing attack in which they capture the username and password. And this is going to be leveraging a cross-site scripting vulnerability. And like I said, I dubbed it cross-site texting. It's just a play on words. There is no SMS injecting into a vulnerable app. It's just a play on words, so I don't want to hear it. I know people like to throw stuff at the end of cross-site. I just figured I'd do it too. What the hell? So that's kind of the first scenario we're going to go over. So a little bit about cross-site scripting. You're going to hear a talk tomorrow of which guys that wrote an extension in Firefox. And they'll probably get a little more than this, but this being the first day, I'll quickly go over it. And it stands for cross-site scripting, this XSS. So at the end of the day, the bottom line is execution inside a web app. You'll see it, different definitions, but that's basically what it is. And when I say code inside a web app, it's usually going to be HTML, JavaScript, Flash. It's going to be some sort of command and control type script or code. And so maybe, as we go through the demo, maybe it'll seem a little clearer. So how does cross-site scripting work? Once again, I got a bunch of shit on my slide there. Either way. It wasn't like this when I did it earlier. Okay. Basically, there's 2 kinds of cross-site scripting vulnerabilities. There's stored and reflected, and we're going to go over here what stored is. And stored basically doesn't require a phishing attack if an unsuspecting user just stumbled upon a malicious or not really malicious, they just stumble upon an app that turned malicious because of this vulnerability, they can be victimized. So what happens? An attacker is they're going to somehow find the vulnerability within the application. They're going to try the request, and you see the bomb attached to the request. What that bomb is going to be, it's going to be the code I talked about before, the HTML, JavaScript, or the Flash. And so they're going to request it and try to inject code and see what happens. In this particular case, the adversary throws it in there, and it gets stuck to the database. And that's where the store part of it comes in. So now it's just sitting there. And then the code is going to happen, you'll see in the next slide. So here comes a user, and they're thinking it's a normal web app, could be Flickr, it could be anything. And they're going to be accessing some information, say a picture. All of a sudden, that script is going to get executed in the background and victimize the user. Yeah. And yeah. And how it usually, you'll see a stored cross-site scripting is maybe in a message form or a comment box. Typically where on applications try to take a lot of input from a user, say like a long paragraph or something, that's typically where you'll see stored, because they have to include a lot of characters, and then that's going to get stored in the background. So when you post something to an app, you say, hey, I think the Yankees suck. That's going to go on the app itself. That's getting stored in the database. And then when you come back to reply to Yankees suck, that's when you'll get it. The malicious user has put in HTML or JavaScript or Flash in the database, and it gets executed on you. And there's numerous of things that can be done at this point, and we'll kind of go into one in a second. Then there's reflected. Reflected has nothing to do with the database. What happens is the app doesn't do input and output validation. And like with most things, if you ever get a user to click on something, it's immediate. So it's the request response, and they immediately get affected. And we'll also look at how you leverage that. That's the real key, is once you have that vulnerability there, how do you take advantage of it? So here we go with the first scenario. So how would an attacker first find the vulnerability? And the guys tomorrow from Security Compass are going to have a little automated tool that's going to aid you in this. But I'll just kind of go over some of the basics of what you're going to try and do. So this is a demo application by the company Watchfire. I have nothing to do with them, but it's a good little demo app to kind of show you the vulnerabilities in web apps these days. So if I'm a malicious user, what I'm going to do is I'm going to look for input. I'm going to find out, all right, this is a nice little banking application. I could probably try the username and password. So I may try some sort of like HTML and see what happens if I inject that, if it comes back. I'm not going to do that here. Nothing happens, it's going to error out. Also, like up here with the contact us, that's usually a good place to do it. And like, oh, you want to fill out our online form. Here's what I'm talking about. This may be a case where something's going to get posted to the database in the background. So maybe other people will be able to view your comments about the bank, and maybe the checking is great, it's free, you want to try it out. So maybe you might see that comment from another user to get stored in the database. So as a malicious user, those are the kind of things you're looking for, is these inputs. And one I want to show you in particular is definitely the search box top right. These are particularly vulnerable because search boxes have to allow a lot of different characters in. So you may want to search for something a little crazy. So what you want to do is maybe just type in the word vulnerable. And you see here, everything looks kosher at first. It just says, okay, we didn't find any search results for vulnerable. And then maybe what an attacker would do is try, all right, well, let me just give the H1 heading here. You can see here what it did was it implemented the H1 heading tag I just put in. So it looks bigger and it has sort of the bold effect to it. And if you kind of wanted to even further verify that, you might try to change the background color. So you want to go body, background color equals black. You see now I've changed the whole look and feel of the application. This isn't getting done in the database. This is simply what is presented to the user. They're not validating the output on the search form. So I can go in there and put command and control type code. So, and it's not necessarily, input isn't necessarily directly in a form. You may want to try some of the parameters that are actually in the URL. Here they're doing a GET request, so this equals to personal deposit. You could try the same thing. You could try the H1 vulnerable. I don't remember this. I don't believe this is going to do anything. So it just gives you an error message. But so it's not just inputs within the web app. You're going to probably do it on the URL as well. Can everybody see the URL okay there? I tried to dumb it down to 800 by 600. So the same thing, you can see where it got URL encoded once I did that. So it's not just input in search boxes or in comment fields. So that's where the second point there is the attacker was going to try to do that for all. Now it sees, hey, I know the search box is vulnerable to cross-site scripting. So how can I leverage that? If I get to my next step. So an attacker would be able to love to manipulate the DOM. And I'm going to show you here what you would do there. I'm hoping. Firebug, in case you've never heard of it, it's kind of tailored towards developers. And it'll quickly allow you to kind of see how the application is built out. You can come over here, and over here is the CSS. You can come over here and say, change this color from black to another color immediately and kind of see without manipulating the application, without secure shelling into your app and then changing some of these things. So it's really handy for developers to see how the app is going to look. But you can kind of use it to also do assessments on applications. So when I say manipulate the DOM, I really mean, and I'll kind of show what I mean. You click on the inspect button here. As I take the mouse and I highlight over certain areas, it's going to show you exactly where in the HTML, or actually where in the DOM, or the document object model, that this particular image lies. So it's in this table data, in this A, and then here's the actual where it's pointing to get the image. So as a malicious user, I want to be able to manipulate the look and feel like I did with that background color. Except I want something, a little more snazzy. Something, and in this case, we're going to do the username and password. And I don't think I had my. Well, let me first kind of show you what. So here, what I want to do. Oh, let me go back. I'll visually get straight here. So on the inspect, you can see here, and I just picked this particular block. And different attackers may choose different looks and feel how they want to do it. So here, this block here is what I'm going to replace. And if you'll look here in the, it's this div tag here. So if I move up and I put my mouse on the header, it's going to go to the header. I'm going to come back down to this div tag here. And it has the ID of wrapper. So I know this whole chunk in blue here is contained within the wrapper ID div tag. So I'm going to go in the search box and then manipulate that div tag to look different to the user. And so I'll go back to my slide here. And this is the injection code that I would place into the search box and then fish it to some sort of user via email or a malicious site. I'll kind of go over some of the code here. This first part is a JavaScript. So here's the first line is JavaScript. Then I'm going to come in here and put in my HTML. And the first line is really important because it says, all right, I want you to go through the document. I want you to get element by ID. And here is where I put in the wrapper. So an attacker would have to know the application beforehand, but that's not too hard because it's publicly available. And then the key here is the, what you'll see in the orange there, is the Innerhtml method. And what the Innerhtml method does is, okay, simply whatever is in this side of this wrapper tag, cram my stuff in there. Get out the developer stuff and put in my stuff. So it's going to manipulate the look and feel. And then here I come in and I say, all right, well, I'm going to tell the user to enter verification information. And here's a form action that's going to go to my site and steal credentials via cross-site scripting. And I'm just going to do a username, password, and then a phone number. So, and then the phone number is going to then text me that information as soon as my phishing attack is successful. So once somebody clicks on this and says, okay, I'll put in my information, and then it'll be texted me. In this case, I would hard code my phone number in there. I'm just going to do it here for demonstration purposes. So let me go to my, I don't have to type it in, I can just cut and paste it. So this is that same code you just saw on the slide. Don't worry about making it bigger. This is exactly the same code. So all I do is I just simply come here and I'll cut and let me get out of Firebug here. So I'll go back to the home page. I'm just going to simply paste that whole entire text into this right here. You can see here now this is what the end user would see. Once you create the phishing attack, they're thinking, oh, okay, I just need to input my information for the bank. That's what they need, right? So that's what I'm going to do. And you can see here that the footing tag stays the same and also the heading tag. Now, you could have kept the left nav. You could have, you could do a little, make it look even snatchier. You could actually manipulate their form on the online banking, their actual form to go to your site and capture that too. But I want to do this for purposes here. So, does anybody have Verizon as a phone service in here? Who wants to come up and put in their information? It's nothing bad. You want to come over and do it? You got your phone on you?
Yeah.
All right. I'll tell you what. You put in a username. Anything. All right. Let me put in the password. Don't look. And then put in your phone number. No spaces. I mean, no hyphens. And it may take a little while, but it won't. Yeah, submit. And you get a t-shirt for that too. There you go. So I want you to tell me what my password is here in a second. Let me know if you get the text message. So once again, in this particular scenario, you would hard code that information, or you could email it to yourself. Simple. It's that simple. So I'll show you. It's oranges, right?
Yep.
Okay, you got it. All right. So, you put it in apples. I was like, I got to do oranges on that one. So, and I'll show you here's the simple PHP server code. Nothing like four lines. You could even do it in less. But so for this case, here's the address, and it had to be Verizon. It wouldn't have worked for some other one. You just email, vText. It's going to text it to you. So, and like I said, in this case, I would hard code that. The subject of his email was phishing attack successful. The username, I'm just pulling that from the code that I submitted to the user. And it has to be the same here. So these would have to match up in the PHP code. So whatever you name these here will have to be reflected in your PHP server code. Or it doesn't have to be in PHP. It could be in any server language. So same thing, using a password there, and then just simply mails it. And then all of a sudden, the header function within PHP simply directs you right to the simply redirects you back to the home page. And that's what happened here. And I don't think, let me quickly do it's not my PC, so I'll quickly see if I can't get tampered data. So I did download Firefox, another Firefox add-on is tampered data. It's simply a local proxy to capture web traffic. And I'll verify to you that it's actually going to my site and coming back. So let me just do another quick copy paste. Wait a minute. Forget how you quickly get the status bar at the bottom either way. The status bar at the bottom.
Status bar.
Huh?
View status bar.
Okay. If I had to find it, it would have taken 10 minutes. Okay. So the status bar, if you look close enough, you'll see where it goes there. I'll just type a jump. It's not going to text you, don't worry about it. I don't know if you can really see it because of the podium here, but it's quickly going to go to my site and hop right back. Never let them remember your password. Either way, so it was really close. It was really fast there. So if I go down to my tamper data, like I said, this is simply going to capture the requests and responses coming from the server to you. So here I can start it. Actually, let me get that set back up first. And then, so here it is again. So I'll do apples and then oranges. And then I'll go back and start my proxy. So start. And do submit. It's going to say, do you want to tamper it? And say yes. So you can see here, can everybody see that okay? Yes. It's actually going to my site. And then it's going to, you see here, it even captured the oranges as the password. So you hit OK. And then the next request is going to be to demo test fire or the home page for the application. So you can kind of see an unsuspecting user wouldn't see that going on in the background. They're not going to know that their information just went off to a malicious site and they got redirected to the home page. You can also authenticate. You don't have to put them to the home page. I could have captured their username and login, authenticated them to the site, let them see their checking account, and still capture their information. I didn't do it for this demo, but this required me to write more code. So, but you could have easily done that as well. I don't run Windows much, so I'm going to be done here. And I use WebScare. I was going to use WebScare for my second scenario, and I have a jar file on Windows. What happens if can you just run a jar file on Windows in it? I've had the virtual machine. Okay, Nick, looks like you got the virtual machine then. Questions anytime, guys. I mean, don't feel like you have to wait till the end. So, I don't know if it's going to work or not. WebScare is notoriously slow. If I can't get WebScare up and running, I may cut my short talk. I didn't see that run.
I got a question.
Travis, you got a question?
Yes. Doesn't matter. Go ahead.
So if I'm actually trying to get into that bank to do my own normal business, how do I know that you're not sniffing my password, and how can I prevent that?
Yeah, exactly.
That's a good
Like
question.
no script?
The real answer is you won't know. Because what you're doing is you're entrusting Bank of America, Wachovia, you're entrusting that their developers developed the right code and wrote the application properly. Now there are some steps you can take, but if it's a widely open vulnerability and a smart attacker, you won't know. Of course, you could run a proxy, but who's going to run a proxy every time they go to log into the bank, or run a proxy anytime they do anything? And so
aren't there any standards that rate these sites so you?
Hey.
I'll repeat questions. The first question was for the video is how do you prevent that, or how would you know if somebody was capturing information. Okay, second question, I'm sorry.
Are there any organizations that actually help you determine which sites are designed correctly so this won't happen? Protect you?
People do that for a living, so I would say no. There is no green bar up top and the URL is going to tell you to save. There's no icon that's going to say hacker safe. Well, there is,
but it's a lie.
It was written by a hacker.
So the question is, who do you trust? That's a really good question. That's something we're struggling with in information security is if I'm going to Bank of America, Wachovia, I'm really trusting them to do the right thing. I know, for example, me myself, I've had all my information on Monster.com. And in Monster.com, yeah, exactly. What they did is they allowed, I'll get to you in just a second, man, I got you. They allowed somebody to do a third-party advertiser. So the advertiser said, okay, yeah, you can advertise on our site, no problem. So what they didn't do is they didn't check the advertisers. They let the advertiser post content on their site, and they were able to steal people's information. Now, of course, I haven't, Monster sent me a notification and all this other stuff, but I trusted Monster.com with my information. Now, it's kind of a crapshoot. I mean, I hate to bring bad news, but I mean, it really is. And I'm hoping through these talks, basically, the process starts in the beginning of the software development lifecycle, and that's hopefully where we can try to capture some of this stuff. So, let me get this guy. That was a great question first, man.
The question I had is the attack that you previously demonstrated, is that a stored attack or is that a reflective attack?
That is a reflective attack.
Okay.
So in that scenario, good question. In that scenario, it's going to have to be a phishing attack. And so this may look slick and pretty, but there's a lot of stuff that would have to go before this, all right? And I don't know if I have the, let me just do, Italian bank, iframe. Let's see, that may be, there you go, boom. All right, so this is the same attack. What happens is, this is an Italian bank. They did the same thing. You see right here. It's really difficult to see. It's in Italian too. So they did the same thing. This was back in January. They did the same thing I just showed you. Instead of doing the Innerhtml, they used an iframe. So they popped an iframe in front of the user. So the user thought through an email that, hey, I need to go in and log into my bank. So they go here. The attacker's popping an iframe. It looks kosher, right? We got all the icons. Even the URL's correct, right? It's not like it's evil hacker and then they just made it look like this bank. They just popped in an iframe and then captured all the information. And this was, I believe, what's the date on this? I'm not seeing it, but I believe this was back in January, if I'm not correct. Yeah, January 8th. So I mean, this was, I clicked on something, but this just happened. So I mean, but the phishing would have to come before that. So
Don't worry, Ajax only makes this all easier. Good question.
Yeah, it's not a question. It's more that the community needs to know that UNC Charlotte's going to be one of the first universities to have a program to basically certify programmers.
okay,
So right out of the chute, the code would be correct secure-wise.
let's hope so.
Good sales tactic. I don't believe it. I code for a living.
I don't believe it.
So
But anyway, it is the first. So.
that's good. No, I'm a fan of UNC Charlotte. But
Don't shill at my con.
what I was going to do on the I could probably do it in Tamper Data, but it's not going to be as slick and easy to do that. What I was going to do with this second scenario is take the same application, not this one. Take this. I'll eventually get this straight. I don't want. No, I don't want IE.
Oh, come on.
Surprise, surprise. What I was going to show here in this same, and I can kind of quickly do it here, was how, what an attacker would do is they're going to go through the application and see how they're generating cookies for the user. And I might can do it. Let me see if I can just kind of hack it together here. So once again, I'm going to fire up my proxy. Let me go ahead and start it. I'm going to log in with with JSmith. It's one that it comes, and the password is demo1234. So we'll say tamper, and you see that all the information here. What you really want to pay attention to is the see, and that's why I don't like tamper data that much. It's going to be setting cookies here. And that's what really an attacker will be looking for, is how does the application set cookies? And I think it's going to, actually that's like the ones that come with, okay, here we go. I'm hoping this is the cookies I'm looking for. So you see here they've gone and you see this cookie called AM user ID. And you see it's this number here, 6014. Well, we come here, and actually the checking account was called 6140 as well. So, and this is easy pickings, which is supposed to be. But what an attacker would do, and what WebScare allows you to do, is to test the strength of the cookies. So what you can do is you can see where an application is setting cookies, and what you can tell WebScare to do is, all right, go ahead and fetch me 500 of these cookies. So it'll do 500 requests and responses for that cookie. And then what it'll do is it'll assign a numeric value to that cookie through some sort of fuzzy math. And then what it'll do is it'll do this, so it has to compare the two cookies. So it gives it numbers to compare the two cookies. And then it gets the difference, and then it plots those out on a graph, and it lets you see trends. Maybe you can see how the cookie is getting generated. Is it random enough? Is it strong enough? And if a malicious user sees, all right, well, they're just going every other, 5, 10, 15, 20 at the end of their long string, I know I can guess the next cookie in the session. And then they would be able to do another user here. And the same thing with, once again, if I had my Firefox, I'd be able to do a little more. But, and matter of fact, what you can do here is actually the next user is the next one. The 60150 would be the next user. So they can just go ahead and then, instead of having John Smith, they would go to another user. So the account history would be 60150 instead of 60140. So sorry I don't have all my tools handy. I don't know what's up with my HP. It's a work machine. It sucks. So I have a ThinkPad, but I didn't bring it. But that's kind of what I was going to go over. So I'll cut my short talk. But the good news is and I guess the same thing here as what I kind of just said, is that the attacker is going to perform reconnaissance on the application and see how the application is generating cookies. And so they probably go ahead and create an account and see what happens once they log in with their account. And maybe they would see some sort of pattern. So, and like I said, all these will be up on either CarolinaCon or my website. And but my talk that I was going to give on the session ID analysis or the cookies is already up on my site. I'm going to post the cross-site scripting and text messaging demo there, and it's all a video screencast. So go there at your leisure, and you can go from there. So sorry for the short talk. Does anybody else have any questions about the first part of my talk? All right, appreciate it, guys.